In this video, I will show how to use TypeScript to build a prefab that has custom logic. So, what I want to add for this scene here is a turret that we can mount to the wall, to the ceiling up there, and when the player comes close to it, that it should shoot at the player. So how to do this? I've prepared a prefab already, and this is the first and most important step. First, we need to build our prefab and decide which parts it is made up of and how it should work. And then later on we add the scripting which connects all of the dots. So at the top of the prefab we have just a node which has a mesh, which is actually this part up here. So this is the top level node with which we instantiate the object. And then below that we have a node which represents the body, and this is supposed to be able to rotate later on. So this can rotate in any direction and then point at the player and shoot. So this consists of our sphere and some other stuff. So I apologize for the really crappy graphics and so on. We don't have any good assets, so this is all made up of scrap parts. But it still is possible to show how to do the scripting with that. Yeah. So if we disable the visualizers and icons here, you can see it a little bit better. We have a gun, we have the body here, and the important parts here are, first of all, to the body we have attached a dynamic actor that is set to be kinematic. And this is for the collision detection later on, so that we can actually shoot back at the turret and we can hit it. So we have this sphere here, which is a shape that can be hit, and below that we also have a box. So together these two are the parts that the physics engine knows about, so that we can hit that. Then we have the mesh below here, just for the visual representation. And then at the front here, at this position, we have a spawn component. So this is this part. And that's the most important aspect for the script later on, because that's what we want to trigger. So if I enable this right now, so currently it is set not to do anything when we play the game, but I can change that. And then when I play this, you will see this is how the turret would be firing. And right now it's just doing that all the time because I enabled that. But I will disable that again, and then later on in our script we want to trigger that manually. So our script decides when to spawn the stuff here. And so this spawn component, this references a projectile prefab. So this is a completely different part that I'm not going to talk about, but every time this spawn component spawns a projectile, the projectile will just do its stuff and then try to hit something. We also have an fmod sound component over here, and that's used for the sound. So currently it's set to paused, but if I unpause that and play, you hear this is one sound, one shot, and later on in our script I can actually go ahead and trigger that as well every time we fire a shot. So these are the things that the script is supposed to trigger. And the script is also supposed to take control over rotating the turret. So let's do that. Our script will operate on the body here because everything above this is just static. This part should not move and shouldn't do anything. The script will work on this here, so we add a script component to this node. So now we have a new script component here, and this needs to reference a script asset. And we can easily do that. We can say, okay, this is my turret prefab. I want to store the script next to it, so that's why I use this workflow over here. I say new and TypeScript. And now the file selection folder will already appear somewhere around here. And I put it into my turret_data folder, because this script really only belongs to the turret and can't be shared on other things. So by putting it into a folder that has the name _data at the end, it will be hidden in the asset browser and only show up if I actually go there. So right now you won't see the script here, but if I click on this folder, then I see it. Okay, so this is our new script. The script editor is read-only. It only displays your current script. And as you can see over here, it references a file on disk. So if I go there, you will actually see that in this folder over here, I now have my turret asset, and I have a file, a TypeScript file for this. So the next thing I want to do is edit the script. And for that, I click on this. And this will open Visual Studio Code. Actually, Visual Studio Code has a bug, so it always opens 2 instances. But yeah, doesn't matter. What you now see in here is that in Visual Studio there's a lot of stuff in here. Basically, if you collapse all of that, you will see that these are the data directories of your project. So you can see that over here as well. We have the base data directory content and our project data directory. And it's similar here. That is needed for Visual Studio Code so that it can know about all of the other TypeScript files in your project and then do auto-completion and so on. So that's why when you open the script from the editor will tell Visual Studio Code about all of these folders. Anyway, this is our script now, and it is already filled with some template code that we can work with. So I want to have a script component that actually updates frequently. So that's why I have my turret class over here, and I extend the ticked TypeScript component. If I want to have a script that doesn't have any update, I can use this version. That's a bit more efficient, but yeah. Then I have a constructor call over here. At the top, I import the easy stuff. So this namespace includes everything from the ezEngine functionality. And then we have functions to initialize and deinitialize. We don't need those because the most important function for setting up stuff is the onSimulationStarted callback. And then in this function, we could register message handlers. I will come back to that later. So, and here we say how often we want the tick function to be called. So the tick function is down here. This is what's called every so and so many milliseconds. And here we can set up how often we want it to appear. So we set this to 50 milliseconds. That means 20 times per second. And then here we have a sample message handler. We don't need that right now. So now this is the basis of our script. And we will start by first checking where the player is. And for this, we use Spatial Queries. And so the turret is supposed to look up in a sphere around it where the player might be. And it needs a way to figure out what the player actually is. And therefore, the player prefab, this thing, which is one of the more complicated prefabs in the game, has a marker component. So that's the blue sphere down here. So if you look at all of the visualizations here, the blue sphere here is a marker component, and it has a radius of 30 centimeters, and it has the marker player. So that means in our spatial queries, we can query for things that have this tag and find them. So if the player runs around the scene, then it will carry this marker component, and our turret can now query for all objects that are close by that have a marker with this thing. So that's what we are going to do here. In our update function, the first thing we want to do is we ask who our owner is. Here you already see that Visual Studio Code has nice auto-completion. I didn't type this, I only typed get owner, and then it auto-completed that you need this as well. The owner is, so this is a component, and the owner is the node, the game object that this component is attached to. So next, we want to ask the world for objects inside a sphere. And here you see, okay, it has IntelliSense. So we want to have the player marker, so we are looking for that. And we want to check around the position of our owning game object. We use a radius of, let's say, 15 meters. And now we need a callback through which this function can report back the results. And honestly, I can't remember the exact way how this callback has to be defined. So with F12 on the function, I can just jump to the declaration, and I can just copy paste this over here. And now I have my callback, so I can go this, object callback. So that means this function will check around this position in a radius of 15 meters, whether it can find any object with the player thing, and it will call this function for every result that it finds. So the next thing that we need is to store that. So we just go here and define a variable. So this is our member variable, and as you can see, I can give it strong typing here. So I just store this one object, and this script is really, it's supposed to show how you can get stuff done, but here we will really just take the first result, and that's it, nothing else. So we return false to say don't give us any more results if you have any additional ones. Next thing we need to do is check, did we find anything at all? This. If we didn't find anything, then we shouldn't continue. Now we actually want to do another check. So we want to check, is the object that we found, can we actually hit that? Like, is something in between? Because this is just a range query, right? This would find stuff through walls and so on. So we want to do another check. Can the turret actually see its target? So we just use the physics system and say raycast, and again from the owner position. And now we need a direction. Let's call that add that in a second. And we need a distance. Okay, we need to compute that first. Okay, so the next thing is the collision layer. And for this, actually, that's, if you look under project settings, physics settings, these are the collision layers. And I want to pick one with which I can hit certain objects and so on. This is a bit more complicated topic. I won't go into that. I just use the visibility raycast thing here. And I happen to know that this is the index 7 because I count from 0, 1, 2, 3, and so on. This is not perfect, but it works. So we use index 7 here. And we want to only check against static shapes. So now we need the direction and the distance. So that's missing. So first we compute the direction vector that's going from our turret towards the target object. So we need that. So that's the direction into which we want to raycast. Then we also need to know how far we want to raycast. And that's just the length of this, this vector. The vector doesn't need to be normalized here, it will be normalized internally. And now we get a result, and the result actually has lots of information, like which actor did we find, how far away is it, what was the normal where we found it, and so on and so on. But all we are interested in is, did we find anything at all? Like, was there a wall in between? So we just want to know, is the result null? And if it is not null, that means we hit something. So we just check, was it null? Was it not null? If so, then, well, early out. Next thing we can do is we can actually trigger firing. So for that, we now need access to our spawn component. And for efficiency reasons, it makes sense to check for components at startup. So when our script runs, this is the first function that will be executed. So what we do here is we first remember that we execute our script on this node. So this is the owner node. And now we need to find another node, specifically this one, and from this one component. That's what we want to trigger. So I gave those nodes names here. So I called this gun and this one explosion. And these ones, they are not bold. That means the names are just from the editor for convenience, but they actually have no names. So first we need to find this node and then the spawn component and store that. So we check, is there some child node, and we just want to check recursively. So it's really supposed to search the hierarchy. And now we want to find a spawn component. So we tell, we say, okay, on that gun object, please find me a spawn component. And we actually need to store that for later. So what I'm going to do is add a variable of type spawn component. I can save that. So now we have a reference to the spawn component, and that means down here we can now go and execute something. So we have a spawn component, and usually when you can tell it to automatically spawn stuff or whatever. But so if you look at this, the spawn component has a delay of 0.1 seconds. That means that if you regularly tell it to spawn, it will spawn prefabs with this repetition. And here in our tick component, we don't care about delays between spawns. All we tell it to do is, yeah, we want to spawn something. And this schedule spawn function on the spawn component will already take care to say, well, I already spawned something within a certain time, so I will delay this until the next time where I can spawn again. So we can fire this 100 times per second, and the spawn component will make sure that it will only actually spawn 10 times per second. This script should already be working. So let's try this out. We can go here and we can click this button to transform or transpile our script, and then you see that the preview updates and so on. One thing I forgot is to test our script, we actually need to reference our script. So I previously created the script, but I didn't actually set it on our component here. So we go to the script component and then select our turret script. Now we go back here, press play. And as you can see, it detected that we are close. And it started firing. And now it stops firing because we are behind a wall, so the raycast doesn't find us anymore. Yeah, it doesn't do anything else. And as you can see, if I go far away, it doesn't stop. So that's a bug in our script. That's because we did find here, but we never reset this. So if I go in here and say this equals null, then if this function doesn't find anything, then this will early out and stop firing. So do this again, starts firing, and now it stops firing. So next step would be to make it rotate towards us. We already have a direction towards our target, so that's a good thing. And now we can go and detect our new rotation that we need. So quad is a quaternion that stores a rotation, and we want to set it to a rotation between the x-axis and this direction. So what does that mean? This is the direction in global space towards the player, and we want to set the turret to the same thing. So we want that it points at the player. So this is the rotation that the turret would need to be set to point towards the player. So because basically we are converting a direction vector here to a rotation quaternion, and we use this set shortest rotation function to do that. And we use the x-axis, so this is just 1, 0, 0, as the basis to rotate from, because our turret points into the positive x-axis. So the red arrow here is the positive x-axis. So we want this part to point towards the player. So this is the rotation, and if I were to set this directly on the turret, then the turret would immediately snap towards that position, towards that rotation. However, I don't really want that. I want it to rotate slowly, and there are many ways to do this in a really good way. And but here we will just rely on the fact that the tick function is ticked every couple of milliseconds, and just use that so that we get a rotation over time. It's not the cleanest way to do things, but it is the shortest. So we lerp from our existing rotation towards the target rotation, and let's just say by 0.1. So slurp is the same as lerp, just for rotations, so spherical linear interpolation. So we interpolate from the current rotation of the object to the new rotation, but only by 10%. And we do this every frame or every tick, and this thus over time it will rotate towards the player. And now we need to apply this. Okay, let's test this. As you can see, turret rotates towards us. It starts firing immediately. And that's a bit annoying. So let's fix that. So to check whether the gun actually points at the player, we just use the dot product. And we already have the direction to the target. So what we do is we normalize this vector so that we can do a proper dot product. So what do we do here? This is the direction from the turret to the player. And this is the current direction of the turret. So this is already normalized because this function always gives you a normalized vector. This we just normalized here. So if we do the dot product between that, then we get a value between -1 and 1, which is the cosinus of the angle. And then we just compare that to some other value. And if this value were 1, that would mean that it would point straight ahead at the player. And if it were -1, then it would point completely away from the player. We just compare this to the value that 15 degrees. So we convert 15 degrees from degree to radian, and I use this utility function over here. And then I put this into the cosinus function. And all of this could be pre-computed. This is actually just a constant, but this is more descriptive of what it's doing. And I compare that, and that means if the turret is already pointing more than 15 degrees towards the player, only then shoot. So if we test this again, now you see it's firing now, and if I turn behind it, then it first needs to turn, so it stops firing, and only when it's actually pointing at me, then it's doing the rest. Okay. Next thing, would be nice to have more sound. So we already have this this sound event over here. So I want to spawn that as well, because as you have maybe have noticed, the turret doesn't make a sound when it fires. So the first thing we want to do again is to get a component for this. There it is. And we do the same here. And just assume that that works. And then down here, when we actually spawn our shot, then we can also go to this component and tell it to do a start one shot sound. That means we can trigger this component multiple times and it will tell the sound engine to do a one-shot sound, and these can overlap, so we can trigger the same component multiple times, and even if the sounds overlap, they continue to play. So let's get back here, and that sounds way more nice. So nearly done. There's one more thing. I actually want to be able to shoot back and to be able to destroy the turret. So the first thing I want to be able to configure how much health a turret has. So for this I use an exposed variable. So in the asset over here, I actually can add variables. So I go in here and say health and give it a default value. And now I need to click this button to actually update the asset, because it will insert this in here, but it will also store this information somewhere else. So now I have this variable here, and I can use it from the script code. And I can also, in here, this variable now shows up. So on the script component, I now have this variable, and I can adjust how much health the turret has. I could also expose this variable from the prefab again by right-clicking, say expose as parameter, and then I could actually modify that for each instance in the level, but I'm not going to do that right now. So if I look at my script code, then Visual Studio Code read the updated text, and now I have this variable here. So first thing, if my turret doesn't have any health anymore, it shouldn't do anything. So that will stop it from doing anything. And now the only other thing I need is to be able to get damage somehow. And that's what my projectiles already do. So if I fire my own gun, then the projectile that hits something will send a message to the object that was hit. And that's the damage message. So all this script needs to do is to react to that. So because this is a C++ message, it is already exposed to the script. So it exists in this easy namespace. And now, okay, so first thing, of course, I can shoot at the stuff that's already dead. So if the turret is already dead, don't do anything. Otherwise, just subtract the damage. And if it's still alive, then don't do anything. And So we now have a message handler, a function, but we need to register this as a message handler. And that's where we come back to this function at the top over here. So here we say, okay, register message handler for a specific message. And here we use the damage message type. And then we pass in the name of the function that we want to be called. So every time anyone sends a message of this type to our prefab, this script can handle it with this function. Of course, now we want to have a nicer reaction. So I already have this explosion object on here. So this is a node which has again a spawn component, but this one references an explosion prefab. So that will spawn a particle effect and a sound and so on. So we can use this to just spawn an explosion. So first we find the game object that's called explosion. And if we find something, then we try to get the spawn component on that. Again, if that didn't work, just early out. So now we have this component, and then we can say that we want to spawn this right now. And there are multiple ways. We can again use schedule spawn as with the projectiles, but there's also one where we can say do it right now with no restrictions. So this is the trigger manual spawn function. So we can say ignore the spawn delay, yeah, and it can optionally take an offset, which we don't want. So this will just spawn the explosion. And because of all of these things, we will spawn it exactly once, and that's it. So let's go in here, play. Now I need to hit that thing. And there you go. It spawned the explosion with the sound and so on, and then it just stopped doing anything. So now you can see that it doesn't rotate anymore. Yeah. And that's our small turret. And that's, I think, enough for a good introduction to how to use scripting to get some game logic into your game. Thank you for watching.